of a function, and then there's a part 2, which would be the x and y intercepts. So when we're talking about the zeros of a function, notice up here, aka, what does aka mean? Also known as the x-intercepts. So x-intercept actually has several names. So we're just going to introduce one of the names today, which is zeros of a function. Okay, but there are actually about 3 more names that we will talk about later. The good thing about the y-intercept, when we get to that lesson, it only has one name, y-intercept, all right? But x-intercept has multiple names. So one name, aka, is would be the x-intercept. So the x-intercept just simply means where your function, in this case, most of these are functions, where that will cross the x-axis. That's all it is, just where the line is crossing the x-axis. So we will be looking at the zero of a function. How do you find it if you have an equation? If you're looking at a graph, well, that's very easy because there it is right there. How do you find it if you're looking at a mapping diagram? And how do you find the zero of a function when you're looking at a table? Right? So I'm going to ask this question, and I'm sure you can answer it. If you are on the x-axis, that means anywhere on the x-axis, what would be the value of y if you land on the x-axis? Right, so let's write the value of y is 0. Thus, you probably have that name, the zero of the function. Okay, so the value of y is going to be 0. So it's going to be very easy to point that out if you're looking at a table. Y is 0. There it is right there. Okay, or if you're looking at a mapping diagram. When you're actually looking at numbers, you just look where y is 0. Let's move on. So the first one, and again, visuals are great because you can just simply look at the graph and tell where it's crossing the x-axis right here. And we just simply write 2. Now, there are 2 ways you can write this. You can write it in set, or if you want to write it as a coordinate, then you would write it as 2, 0. Okay, so the choice is yours. I don't care if you write it as a set, which means there's only one, you have your one x value inside of the set brackets, or you can write it as a coordinate. Okay, but just know when to use parentheses and when to use the set, right? So here's a parabola, and parabolas sometimes, not all the times, cross at 2 different points. So you can have more than one intercept. So in this case, this looks like it's at 3 because it's in between 2 and 4. And this looks like -5. And again, if you use set, it doesn't matter which one you write first because I'm not writing them as coordinates. Okay, if you wanted to write it as a coordinate, you would say -5, 0 and 3, 0. All right, next one. So what happens if these are your directions? Find the zero of a function, and you're given it as an equation. So let's recall what we already know about function notation. Remember we went over function notation and we had like f of x, and it can be g of x, it can be anything of x. So what is another name for all of these? Very good, y. So we just said a few minutes ago, if you are finding the zero of a function, that means the x-intercept, then that means the value of y is 0. Anytime you're on the x-axis. So where I see y, because remember again, g of x is the same thing as y, I am going to replace it with 0. So I'm going to say replace g of x with 0. So once I replace it with 0, Okay, once I replace it with 0, then I'm going to solve it for x. So subtract 10. And then multiply by the reciprocal of -1/2, which is -2. So that'll give me 20 for my x-intercept. So I'll just use the set, and my answer is 20. And I'm going to put up here solve for x. So that is how you simply find it if you are, and the good thing about being able to have an equation and find the 0 of a function, because you may not always are able to read it from a graph, because if it comes out and it's not like an integer and it's a decimal, you can have decimals as an x-intercept. Then you need to know how to do it mathematically, okay? All right, let's move on to this one. Same thing. Anytime you're given an equation, it doesn't matter if it's in slope-intercept form or some other form, and actually this form is called standard. It doesn't matter what form it's in, you're just going to replace y with 0 and solve for x. So I put these little side notes there, so if you're at home and you forget, you can also read it or you can review the lesson again. Okay, so I'm just going to cross this out because anything times 0 is 0, so I don't even need that. So 4x equals 12, so when I divide, I'm going to get x equals to 3. All right, so that x-intercept is 3. Okay, that's where that line would cross the x-axis. All right, moving on to a mapping. So on your test, I'll probably say, use the relation, which is a set of ordered pairs, and create a mapping. So this is what you would do. Now, you don't need to rearrange any numbers. So you'll just call the first one x, the second one y, and you really just put the numbers in just like you see them as they're listed in the set. So I'm just going to say 1, 0, and 3. Okay, that's the way they're listed. 1, 0, and 3. And then I'm going to do the same thing for the y. So they have to pair up. So -6, -9, and 0. Now, we do show arrows pointing how they pair up as an ordered pair. So we just simply draw arrows to show that 1 pairs up with -6, 0 with -9, 3 with 0. Now, it's asking for the 0 of the function. So I simply look in the table, look where y is 0. So that has to be the x-intercept, which is 3. Okay. So as you can see, there's not a whole lot of computation unless you have an equation. All right. So the same thing if you're doing a table. Table and mapping are very similar. You just put the numbers in the table in the same order that you see them listed. So 0, -2, and 3. And same thing for the y, 6, 0, and 0. So notice in the table this time you have 2 places where the y value is 0. So this must be a parabola. Okay, because it's, it could be because it's cutting across the x-axis at 2 different points. So you write down the x values, 2 and 3. X and y intercepts. So we've just covered the x-intercept. And what do we say another name for x-intercept was? 0 of a function, okay, the 0. All right, now we're going to talk about the y-intercept. So up here it says the x-intercept is where y is 0. So the y-intercept is where x is 0. So it's just the opposite. Okay, it's just the opposite. The only thing is the y-intercept only has one name, y-intercept. So we're going to be looking at the X and Y together. So you can definitely tell from a graph where it's crossing the X or the Y axis. We'll go over this again. Replace Y with 0 or replace X with 0 if you're looking for the Y-intercept. And then, of course, if you're looking at a table, how to get the X and Y-intercept from the table. Okay, so starting here. All right, everybody take a look. It says identify the X and Y-intercepts. So here you can just say the X-intercept, since they've already written it in words, just say equals 2. Okay, it's crossing the X-axis at 2. It's crossing the Y-axis at -3. So a lot of times, you know, we've seen release tests where on your SOL, this could be like a technology enhanced question where you would place a dot on the Y-intercept and a dot on the X-intercept. Okay. All right, identify the X and Y-intercept. You can definitely write them as coordinates, or you can just say X equals 3 and Y equals 0. Okay, so actually we have 3 and 0 for this one because that will be your X-intercept, and since it's at the origin, then the Y-intercept will also be 0. Okay, any questions on that one? Okay. I mean, this is a pretty basic, you know, visual lesson for the most part. All right, let's take a look at the graphing one. Now, if you're graphing, it tells you what to graph in this case. So you're going to graph -1 on the X, so I put a dot there. And then you're going to graph 3 on the Y, so I put a dot there. Now, I didn't connect them, but you can go ahead and connect. And just make sure you put arrows on both ends. Okay. And then for this one, same thing. You're going to put on the X-axis, you go to 2. On the Y-axis, I think you guys just make that a 5. Because I had 6 on mine, so I changed it to a 5. I think yours only goes up to 5. Is that correct? Yeah. All right, and then just go ahead and connect the 2 like we did before. And use arrows. Okay. And then this part right here, guys, this is where you want to pay close attention, right? So when you're finding the X and Y-intercept, mathematically, you have to do it twice. You write down the equation 2 times. Okay, so yours, you know, when you get the problem, is only going to be written once. So you would write it down again like you did over here. And then in one side, you're going to replace X with 0. And then in the other side, you're going to replace Y with 0. Okay, so that's what we did here. This side, replace X with 0. This side, replace Y with 0, okay, because we're finding both of the intercepts. And then you just figure it out, do your math, and you end up with Y is -3. So then I wrote it as a coordinate. X is 1. X-intercept is 1, so I also wrote that as a coordinate. Okay, yes, you could also do set for this. All right, any questions on that example, because you're going to do the next one on your own. So all I did was simply replace X with 0 in one of them because they're the same problem, and then replace Y with 0 and solve for the other variable. All right, so I would like for you to do number 6, try number 6 on your own. Do the same thing, replace X with 0 in the first one, and replace Y with 0 in the second one. Okay, and then get your 2 answers. All right, so you should have these 2 answers, 6 and 2. You could also, like I said, write them as coordinates.